Hello everyone, it's me Hanina Afrin. Today I'll be talking about an important concept in mathematics, that is types of functions: injective, surjective and bijective. These functions help us understand how elements from one set are mapped to another, which has applications in computer science, cryptography and real-world problem solving. Let's begin. Introduction to functions. Before diving into injective, surjective, and bijective functions, let's quickly recall what a function is. A function is a rule that assigns each element from a set called the domain to exactly one element in another set called the codomain. Depending on how this mapping happens, we classify functions into different types. Let's explore them one by one. First, let's talk about injective functions, also known as one-to-one functions. A function is injective if different inputs always produce different outputs. This means that no two elements in the domain map to the same element in the codomain. Mathematically, we write this as f of x1 is equal to f of x2. That is, x1 is equal to x2. Graphically, if we draw a horizontal line anywhere on the graph, it should intersect the function at most once. If it cuts at more than one point, the function is not injective. Next, we have surjective functions, also called onto functions. A function is surjective if every element in the codomain is mapped by at least one element from the domain. In other words, no element in the codomain is left out. Graphically, a function is surjective if its range covers the entire codomain. That means no gaps are left in the codomain. Bijective function. A function is called bijective if it is both injective and surjective. This means it is one-to-one and onto, ensuring a perfect pairing between the domain and codomain. Mathematically, a bijective function satisfies both conditions, injectivity and surjectivity. Bijective functions are special because they have an inverse function, meaning we can reverse the process and find out the original input. Now you might be wondering, where are these functions used in real life? Let's look at some examples. Injective function. Assigning unique student ID numbers in a school. Each student has a different ID and no two students share the same one. Surjective functions. Distributing prizes so that every participant gets one. Even if multiple people get the same prize, no prize is left unclaimed. Bijective functions. Assigning one seat per student in an exam hall. Each student gets a unique seat. Now let's quickly summarize. Injective means different input gives different outputs. Surjective, every codomain element has a pre-image. Bijective, a perfect pairing between sets. Understanding these function types is important in mathematics, computer science, and even real-world applications like data encryption and network security. That brings us to the end of this session. I hope you now have a clear understanding of injective, surjective, and bijective functions. Thank you for your time. If you have any questions, feel free to ask.